Okay, it's on the hour, so we're going to go ahead and get started. I want to welcome you to this ASC-sponsored webinar on enhancing item quality. My name is Belinda Brenner, and I am the Vice President of Client Solutions at Assessment Systems. Want to just give a reminder that one live attendee will receive a one-on-one consultation with Nathan Thompson, who is our CEO and a well-recognized psychometrician. So that's an added bonus for attending today. I would also like to just remind you to keep your mic on mute. We will have hopefully time for questions at the end, and you can also put questions and comments in chat, and I will pick those up at the end as well. So I think we're ready to go ahead and get started. So as I mentioned, I'm currently the Vice President of Client Solutions at ASC, but I have about 20 years experience in assessment. I've worked for 3 healthcare certification organizations, and as a result have experience in item writing and content development. But I didn't come from a psychometric or a test development background. I do have a master's in education, so I have some foundation in the basics of educational measurement. But my first real exposure, as I'm sure is true of many of you on this call, was when I actually went to work for a certification organization or an assessment organization. So I think because of that, I have an understanding of an appreciation for those who are not formally trained in psychometrics and have to learn on the job. So I tend to concentrate on the practicalities of what is needed rather than the math or statistics. So that's my approach that I will be taking today. Now, some of you may recognize some of these questions, and perhaps that's why you're attending today's session. You may have some surprising results. Your pass rate may be higher or lower than expected. We don't know if that is because of, and you don't know whether that's because of the test taker's ability or because you have a feeling maybe some of your items are poorly written. Your item writers want justifiably feedback on their items, and you're uncertain of what's the best feedback to give them. Or maybe you do have statistics from a psychometrician, but you just really don't know exactly what they mean or how to use them in your item writing program. Or perhaps you're getting some complaints about your test items and you're beginning to wonder about their quality. So all of those things are things that we hope to address in this webinar today. So therefore, the objectives are really to place the use of item performance statistics in the larger sort of ecosystem of an item development program that's based upon continuous improvement. So we're going to take a look at the role of data and how it's used in the item writing process. We'll, especially for those of you who are maybe new to assessment, we're going to define some of the key metrics and statistics that are used in item quality and how you interpret those to identify strengths and weaknesses. And then we'll take a look at some examples of some items and their performance, so you can look at and practice on identifying which are low performing that maybe need to be improved, revised, or eliminated from the test. And lastly, we're going to discuss a framework of continuous quality improvement that uses item performance statistics and data. So this is the topics that we hope to cover today. And we'll begin with item development, an item development quality framework. My background is actually in healthcare and healthcare quality improvement. And one of the things that I was introduced to when I used to work in healthcare was the Donabedian model of quality. And the concept behind it is that information about healthcare quality can be drawn from three categories of evidence: the structure of care, which would include things like the qualifications of the healthcare provider, or the physical facility that care is delivered within, the equipment, etc. And then the actual process of care. Were clinical practice guidelines followed? How are you being treated? How were you diagnosed? And then lastly, the outcomes of care. Did the patient improve? How long were they in the hospital? Those sorts of outcome metrics. In assessment, when we think of quality, we think of it in terms of validity, reliability, and fairness. But I think the Donabedian model can still be used because the evidence that we get about whether assessments and assessment items or questions are reliable, valid, and fair can also be considered in terms of structure, process, and outcome. So with regard to structure, it would be things like making sure you have subject matter experts included and that you have a well-rounded and diverse group of subject matter experts so that you can handle all of the depth and breadth of the test blueprint and the questions, that you do have test blueprints that are well written so that you and the candidates or the test takers know exactly what's meant to be tested. And then that you follow item writing guidelines. As far as structure goes, you want a structured process that you follow so everybody knows what is being done, what needs to be done and when. And that includes a solid item review. So that's not just the item writer who's looking at that item, but there's a staged review process. And then that you field test your items or pre-test them before they're actually used as scored items on an assessment. And then lastly, you have performance data, not only data about how your candidates have performed on the test, but also how well the test itself is performing and how well the items are performing. So today we're going to talk about that structured item review process and also performance data and how you use those two things hand in hand to enhance your item quality. The seminal work on item writing guidelines has been done by Thomas Halladina, who I believe is a professor at Arizona State University, and his colleagues. Beginning in 1989, they wrote an article that examined common item writing guidelines that were used and actually looked at empirical evidence as to whether they improved item performance. And then they refined those guidelines in 2002 and in 2013. So in a new manuscript that I believe has not been published yet, so it's brand new, Daniels and her cohorts, colleagues, including Mark Garrell, developed and took the Halladina guidelines and put them into something they referred to as use-inspired guidelines. So they actually simplified them because they determined that of all of the guidelines that Halladina and his colleagues had developed, that there were really three main guidelines that were based upon practical directives on how items should be written. And the first guideline that Daniels described as use-inspired was write the STEM and the answer options. The STEM or the prompt and the answer options. So they determined which Halodyna guidelines that fit into this particular overarching guideline. I've broken them down into do's and don'ts of item writing. So the do's are things like being able to connect the item to a specific content area. That's why we want well-developed item writing guideline, test blueprints, excuse me. It can also be very helpful especially if you're developing a certification exam or a licensure exam, that you actually use references and you cite the reference in the metadata that you have with the item. And that's another way of connecting the item to the content area. You want to write the STEM or the question or the prompt as positively worded, and it should contain the main idea. What do I mean by that? Well, if you think about an item that just says, which of the following statements is true? There's no main idea in that particular question. And that means that it doesn't help it's not as user-friendly to the candidates because it doesn't help their sort of thinking and what they're going to see in the answer options. Plus, it means that the answer options could be very disparate things. And so it's harder to connect to the actual content area on a test blueprint. And then to avoid things like queuing by making all options of equal length and complexity, because test-wise candidates who may not understand the test content, but they're good at taking tests, may be able to look at an answer option and see from cues in that answer option, such as that they're of unequal length or one looks just different in some way. And that may guide them in being able to guess the correct answer. And then the don'ts are things like not to use all of the above or none of the above, or combinations of options. A combination of options would be an example of, less than 5, or greater than 1 and less than 5, and then greater than 5 and less than 1, or greater, so that they are overlap. And to avoid definitives like always or all or negatives in the items, because those can serve as cueing as well, particularly if they're in the answer options. Another use-inspired guideline is to support comprehension. And this means that we want to test the candidate's knowledge. So you want to make sure that what you're testing is the knowledge and the comprehension of that test taker. So you want to minimize anything and maximize things that would make them easier to read and easier to comprehend. So you would bold or capitalize important words in the STEM, like best, most, those kinds of things. Of course, they want to be grammatically correct and with the correct spellings and appropriate vocabulary. Sometimes in professional examinations, the organization or the profession has its own lingos, and for instance, acronyms can be part of that. So you want to have some guidelines in your own test-specific guidelines as to which acronyms are appropriate to be used alone, if any, and which actually needs to be spelled out, because you may not be testing, or you probably aren't testing on what the acronym means. You're testing in the other context surrounding that acronym. And then minimize the amount of reading or linguistic complexity needed. I always say that is avoiding the fluff or the window dressing. Include in the item what's actually needed to answer the answer correctly, and eliminate the incorrect responses or the distractors. And then formulate them vertically. So in a 4-option multiple choice question, it would be A, B, C, D vertically, rather than A, B on one side and the C, D on the other side. And then the third use-inspired guidelines is to minimize construct-irrelevant variance. And so what is construct-relevant variance? It's when a test measures something it's not supposed to. So it adds noise to the results. You don't know if the results are reflected of the candidate's ability on the knowledge and the construct in question, or is it due to something else? I remember years ago when my daughter was in elementary school, she came home with math homework. And one of the items on the math homework was add the number of days in March with the number of days in April. And it was an addition test. All the rest of the items, the questions dealt with adding. Well, that could be construct irrelevant variance, because is knowing how many days there are in March and knowing how many days there are in April really related to your ability to add. So that's an example of something that adds noise to the results of whether, in this case, my daughter would get that question right or wrong. I mentioned that item review is a critical step for your item development process. And there are really 4 different types of review that you want to make sure that you have a standard process for doing. And the first of those is the content review. So this is where you need SMEs to review the item and to make sure that the item, subject matter experts, to make sure that the item is current, appropriate to the test and the purpose of the test, and it's current. You're not testing obsolete content. The second kind of item review doesn't necessarily need to be performed by subject matter experts, and this is style and formatting. So you could have a copywriter or a content editor review the item against item writing style guidelines. So you should have style guidelines for your test. And then a non-subject matter expert can review the item just to make sure that the items are clear and accurately present the question. It's not ambiguous, and the potential responses, and that they're grammatically correct. And then the third kind of review that you can do before the item's even administered is any sort of potential bias. So this would be a sensitivity review. Are the items fair to all groups of test takers? An example of that kind of review would be looking for words that may be unfamiliar to candidates whose native language is not English, or they aren't English as their first language. And using those words that have nothing to do with the question and their knowledge of the content. So an example of that would be an item that deals with, it's on a medical test, and it deals with an injury to the patient. And it says in the item that the injury was due to the patient playing soccer, and a soccer injury. Well, we know in other parts of the world, soccer is not the word for the game, it's football. So if you're administering this test globally, you may be disadvantaging test takers who don't recognize the word soccer, which has nothing to do with actually the content of the item. And in that case, even putting how they were injured may be window dressing or fluff that could be eliminated. So those three kinds of review, the content review, the editorial review, and the sensitivity review, should be performed pre-administration, before the item's ever administered for the first time. And then post-administration, you want to usually conduct some sort of field test or pre-test before the items are used for scoring, by most commonly in pre-test seeding them into a test as unscored items, so that you can collect performance statistics, so that you're able to understand how the item is performing. Is it of the appropriate difficulty, and does it discriminate between high and low ability test takers? So with that in mind, we're going to look at some commonly used item performance data, which are, as we were talking about Donna Bedian's model, which is the outcome data, specifically related to how the items are doing. So some key concepts, and here I'm referring to multiple choice questions and classical test theory statistics. There's also other statistical methods for assessment called IRT, or item response theory. We're not going to get to that today. We're just going to talk about the classical test theory. And two of those most importantly related to item quality are difficulty. And the first one is difficulty. And difficulty, this is kind of like Goldilocks and the Three Bears, because you want items that are not too hard and not too easy. If everyone's getting the item right or everyone's getting the item wrong, it's not telling you very much about the knowledge of individual test takers. And so it's not an effective tool for gathering information on test taker knowledge, because everybody's getting it right or everybody's getting it wrong. It's measured by something we call the p-value, and the values range from 0 to 1. Depending upon the purpose of the test and the quality of your item bank, the actual desired value is usually somewhere between 0.2, meaning it's a harder item, all the way up to maybe 0.9 or 0.95. And anything above or below that, once you gather the item statistics, should be reviewed by subject matter experts to make sure that the item is appropriate. So that's what I meant when I was referring to not having items too easy or too hard. And then the second statistic is discrimination. And discrimination is more like a hurdle. Items should have a minimal positive discriminating power. So discrimination is measured by a statistic called usually by a statistic called the point biserial correlation, and values range from -1 to 1. Anything closer to 1 means that it's better able to distinguish high ability test takers from low ability test takers. So it has a higher discriminating power. You definitely don't want anything in the negative range, because that means that lower test takers are doing better, lower ability test takers are doing better on that item than their higher ability test takers. ASC has a standalone product called ItemMan, which actually is item analysis software for classical test theory. And ItemMan provides statistical information in graphical and table format. And I'm mentioning it here because we're going to take a look at, if you were to use ItemMan, what information you need to put in as inputs into the system to make sure that you get the right outputs. And you can also see on this slide some of the graphical and table information that is provided in item N. So some of the data analysis options that you have, which you need to understand because those inputs can influence the data that results from it. The first one of those is the acceptable difficulty range. That's where I was talking about you don't want them too easy or too hard. And what item N does is put a flag on the item based upon what you provided as the acceptable range. So if you put that the acceptable range was between 0.2 and 0.95, anything with difficulty below 0.2, which means that less than 20% of the test takers got the item wrong, would be flagged in item N. And we'll take a look at what the flags look like in just a minute. And anything over 0.95, which means that 95% of the candidates got the question right, would also be flagged. We're not going to talk about the acceptable mean range for polynomous items. That means if you have items that are partially scored, they're not either right or wrong. So we're going to skip over that. But we also want to look at the acceptable correlation range. This is the discrimination, the point by serial. And so here you might want to have a flag that was 0.2. You definitely, so then anything that would be negatively discriminating would be flagged, as well as anything that's positive but has a very weak positive discriminating power of below 0.2 would be flagged. So you can set those flags yourself. And then you also want to consider if you exclude omits from option statistics. What that means is if you don't exclude them, any omit, and by what I mean by that is if the candidate skipped the item and didn't answer, or perhaps ran out of time and didn't get to the final questions on the test, would be included as an incorrect response for the candidate. So you need to make a decision if those, you really want to count those as incorrect, or you want to exclude them for the admit from the option statistics. And in a lot of cases, you may want to exclude them. And then finally, you want to determine if you want to correct the item total item score correlations for spuriousness. And what spurious means is that the correlation can be artificially inflated because the item is included as part of the total item score. So if you correct it, it removes the item from the total score before it calculates the statistics. So it doesn't have that artificial inflation. And this is particularly important, and more important, the shorter your actual total test is and the less total number of items you have. So once you've determined what your input needs to be, then you when you run item N, this is an example of the item statistics you will get. And so here we have just, where it was on the test, the item ID, what the key or correct response is, if it was scored or if it was a pre-test item that was just being included because we wanted to gather item statistics. And all of these are 4-option multiple choice tests. The number of candidates you had take it, the p-value, which is a measure of difficulty, and then the discrimination or the total point by serial. Another kind of discrimination is the RBIS, but we won't be talking about that today. And then if you look at column J, that's the Cronbach's alpha statistic. That's a measure of the overall exam reliability. So usually what's desired for high stakes tests is anything above 0.9. On the test that these items were drawn from, the Cronbach's alpha was 0.88. So if you look at column J, we'll look at some of the statistics there in a minute and explain what they mean. And then here are the flags I was talking about. So HP means that this item has a higher probability. The flag for this was set at 0.95, and this is 0.954. So that means over 95% of the candidates who saw this item got the item correct. And then K means you need to take a look at what the key is. And that in this case is because it has a low discrimination. It's actually negative, which is something that's not desired. So looking more at these statistics, if we look at the first item, the total point by serial is 0.4, which is good. And I mentioned that the overall alpha for this test, or Cronbach's alpha, was 0.888. So what the alpha W/O means, that means the alpha without. So that means that if we were to remove that item from the test, the overall reliability would actually go down because it's a good performing item. And the p-value is 0.77, which means that just over 77% got this question correct. Looking at another one of these items, I already mentioned that this one would be flagged based upon the flagging criteria we put in because it's easy. And then the next one we're going to take a look at is this last one, that you can see that it has a negative point by serial, which means that lower ability test takers are getting the question right more than higher ability are. So it's not discriminating. So you would definitely want to take a look at that. And then the NA, the reason it has NA in the alpha column J, is because it's a pre-test item. So it's not included in the overall exam statistics. And then the last item, about 29% get the question right. We put our flag here at anything less than 0.3 needed to be flagged. So that's why you see the low p-value flag. You can also get through item-man and statistics that you want to get and gather are what's called a distractor analysis. So this is in addition to item level statistics. You also need to review the answer option statistics to see how the distractors perform. Incorrect responses, the distractors, should be plausible, but they should be clearly incorrect. So here the little asterisk means that it's the key. So it would actually have the stats for the key as far as probability or the p-value, and the point by serial would be the same as the p-value and the point by serial for the overall item. And here we can see the key has a negative point by serial, which is not good. Some other stats to take a look at would be answer B. That's a non-performing distractor, which means that no one's selecting it. So it's just kind of there. It doesn't really serve a purpose on this test. It's too implausible, so no one selected it. And that means that if you can immediately eliminate an answer option, the probability of guessing the right answer is now reduced or increased from 1 in 4 chance of selecting the right answer to a 1 in 3 chance. So when this item's reviewed, we also need to take a look at that distractor and try to change or improve it. And then this is the answer option that has the best point by serial. It's positive. So we would definitely want to review it to make sure that it is not the correct response, meaning that this item has been miskeyed. The correct response is incorrectly identified, or perhaps it's another correct response. So instead of having one correct answer, we have two. So this item would definitely need to be reviewed for the key, and it would also need to be reviewed for distractor B to try to improve and beef that up. If the item can't be improved, then it should definitely or should be retired because it is a negative point by serial. Another thing that you can take a look at, and that item man will provide, or what are called quintile plots. You can either do them as quintile or quartile plots. But if it's a quintile plot, it means it divides the test takers into 5 equal groups. Those with scores up to the 20th percentile, which are the lowest performing category, from 20 to 40%, 40 to 60%, and then 80 to 100%, well, 60 to 80%, and then 80 to 100%. And so it then plots the p-value, the difficulty value, what percentage of candidates got this question right at each one of those quintiles. This is a strong item because the key is A, and you can see the better performing items, the better performing candidates got A correct. So you want kind of this curve for the key, which would be looking at it, how you can tell that this item is actually a strong item. Now let's look at a weak item to compare. Here the answer, the key is still A, but A is the blue, and stronger performing candidates are selecting answer option B more frequently than they're selecting answer option A. So this is a weak item that we would definitely want to take a look at. We don't want the quintile plot to look like that. So how do we use these kinds of item statistics in the item review process? Well, I've already mentioned that in some briefly, but now we're going to look at some examples. But before we get to the examples, it just kind of by way of introduction, the post-administration performance stats sort of serve as a filtering or screening tool. So for pretest items, we want to determine which items are okay to be used as scored items, and which items need to be looked at by subject matter experts because they're not performing as well as we should. And then for operational items, we want to make sure those that have been scored, we want to make sure that they continue to perform okay. So we kind of put them in 3 bundles: well-performing items, depending upon your process. Sometimes with the well-performing items, you can okay them if this is what your procedure says for continued use without having subject matter experts look at them again because they had already looked at them in the item development process. And then the ones that are performing so-so, the stats aren't great, but they're okay. You would want subject matter experts to look at those just to make sure they are indeed okay from a content perspective as well as a statistic perspective. And then the poorly performing items, again, depending upon what your guidelines say, you can either retire them automatically or if have subject matter experts to look at them and review them. Perhaps they'll go into review status with the goal of trying to revise them. Again, how you use the 3 buckets and what decisions or disposition you make depends on a number of different things. One is the purpose of the test. How rigorous do you need to be? the quality of your item bank, and also the number of candidates that you have. If you have a very low volume exam, let's say less than 100 or 50 test takers a year, you might want to rely more on content review than you do on statistical reviews. So you might have your subject matter experts review more of those items rather than automatically making a decision. So let's look at some item statistics in relationship to an item. So we actually looked at these statistics for this item earlier. And this was the one where we had the negative point by serial. So the question is, which of the following substances is a good conductor of electricity? Okay, and the correct response is A, but we can see that silver, which is C, actually had more of the higher ability candidates were selecting it. And about 60% selected copper and about 36% selected silver. Mayonnaise, which is a totally nonsensical answer option, was B, so no one selected it. And again, if this were a test on your exam, you would want somebody who is familiar with the content, a subject matter expert, to look at it. But what we can tell here is that actually both copper and silver are conductors of electricity, and silver is actually a better conductor than copper. So that's why this item performed as it did. So what would need to happen is this item would need to be revised by selecting either copper or silver as the correct answer, and then removing the other, and fixing mayonnaise and including something that's more plausible here. Or if you wanted to perhaps make a more discerning item, you could ask what is the best conductor of electricity, and of those, silvers would be best. And again, following the item writing guidelines that we looked at earlier, best would probably need to be capitalized in the question because it is an important word. Here's another question. And this is, which of the following effects is a result of deforestation? You can see nobody selected A or B, so those are non-performing answer options or distractors. And actually then, if you can immediately eliminate those, the guessing probability becomes 1 and 2. So I would have, even if I didn't understand the content, but I could eliminate those enough to determine the correct answer, but I could eliminate those answer options, then the guessing factor becomes 1 and 2, or 50%, rather than 1 and 4. And the reason why that might be happening is because those who are good test takers recognize that C and D are almost exactly the same. One is decreased and one is increased. So that probably means, from a test-wise perspective, that one of those two is the correct response. And so I'll eliminate the other two, and then if I don't know which one it is, I'll just guess from those two. And so that's an item writing guideline. You don't want to put any cues in the questions, so don't have pairs like this. Just like you shouldn't have them the answer option be a lot longer, the correct response be a lot longer in length than the others. That would also be cueing. Looking at these, what can we tell about this? Well, A is the correct response. Again, it has a negative point by serial, and C was meant to be a distractor or an incorrect response, but we can tell that the majority of, or more candidates went for C then they went for A, which was intended to be the correct response. And C is the also has a positive point by serial. So again, this item would definitely need to be reviewed, and you would want your subject matter experts to definitely take a look at C to confirm that it is not the correct answer. And even if they confirm it's not correct, the item has something going on with it. That means that test takers are not understanding what's being required. Either it's written ambiguously, or there's some other problem. So this is probably an item that would need to be either retired or revised. And so you can actually, with the flags, you can tell, and it's helpful for the subject matter experts to understand what they specifically need to look at. They don't have to understand necessarily all the ins and outs of the stats, but to tell them, you know, C is the answer option that more people are going for and the higher ability test takers are going for. So can you please take a look at it to make sure it's not the correct answer? Also interpreting the quintile plots. So for this one, which answer option would you expect or hope to be the correct answer? Well, that would be A, because it's the one that the majority of test takers are, that higher ability test takers are getting right or selecting. And then what can you tell about option D? Option D is over here, a straight line on 0. So nobody selected it. So that answer option is contributing nothing to this item. And it's making it more probable that candidates would actually be able to guess, again, from 1 and 4 to 1 and 3 of being able to guess. So we'd want to revise answer option D. And what answer option would you expect to be the correct answer here? Well, that's kind of a trick question because it's difficult to tell, because this is kind of all over the space. The higher ability candidates are selecting all 4 of them. And so it's hard to tell which one is the correct response. We don't have the kind of curve or the kind of plot that we would expect from a high quality item. So next, now that we've looked at the statistics, I want to talk about how we can use technology in item development to actually improve our item development process and make it more efficient. Probably the most expensive factor you have in your certification program or in your assessment program is the money you spent on developing good quality items. So how can we make that process, which is also lengthy, more efficient and potentially bring down the cost per items? Well, here's some ideas. We've heard of automatic item generation actually for a long time. And what it means is it's a process that produces large numbers of items using automation and rules-based item models or natural language processing. So it produces a lot of items at once. So that means that then you have the expert review, the subject matter expert review of those items. So they're not involved as much in writing the items, but they do need to review them. Perhaps the most difficult part, if you've written items, of writing good items is coming up with the distractors, those answer options that are definitely wrong, but they're also plausible. So another way technology can be used is something called intelligent distractor generation, using AI to generate plausible distractors. So then you would have the technology assist you in writing the distractors, but you would still need expert review to review the distractors that they come up with. Automated item review means that automation is used to review items against item writing guidelines, those guidelines like the Halodina ones that I mentioned earlier, or perhaps your own, in addition, your own item writing guidelines for your program. So automation would be used. It would take those guidelines and review items against them for flaws, bias, things like linguistic simplicity, how cognitively complex they are, so that you can cut down some on the need for subject matter expert review. It can perform kind of the automation can perform kind of the first level of review. And then another way that you could potentially use automation is chatbot assisted authoring, which means that items are co-created by technologies and humans by having item developers interact with the chat box to create items. And then the last method that I was thinking of is what I called summarization and data extraction. That's kind of content mining. So AI tools can be used to summarize course content. So for instance, textbooks, or to extract key concepts to identify ideas suitable for item development. So sometimes one of the other difficult things of writing items is just coming up with the idea. So if you were able to use AI to kind of summarize a textbook or an article for you and identify the key concepts, that might be a better way of coming up with ideas for item writing, or a quicker way of coming up with ideas for writing an item. You could also do that to perhaps compare your item bank to, or items that you already have items written in using keywords to determine areas in that textbook based upon your content blueprint as well that are lacking or that could be used for new items. So with all of these methods, human oversight is required, and they are really a combination of technology and experts. So it's an interactive exercise. Doesn't mean subject matter experts are going to go away. Doesn't mean you don't use humans. It's an interactive exercise between technology and experts to make the process more efficient. And so lastly, the whole goal of this is continuous quality improvement. So thinking about this in the PDA cycle, which is a continuous improvement model, the plan aligns roughly with the structure in the quality model I was talking about earlier. The two are the do, with process, check with outcome, and then action is required in order to lead improvement. So what this means from a item quality perspective is that to create good quality items, you need to have a plan. And that plan includes, obviously, a well-written test blueprint, a good idea of the item types and the item formats you're going to use. Is it 4 answer option multiple choice? Is it 5? Is it something else? Having item writing guidelines, both using the general item writing guidelines like Halodina, but also your own exam-specific guidelines, and providing those to your item writers and your subject matter experts who are writing and reviewing items in an item writing manual, and then providing training. And that's not just one time we're training and then they're good to go. They should have repetitive training or refresher courses as well. And you can use reviewing the items against statistics as part of that refresher training and part of that item rating training. Next, the do. You want to include subject matter expert review as well as editorial review. Items that are poorly written because they aren't grammatically correct will confuse candidates. So you want to make sure that you have both the peer review, the subject matter review, and the editorial review. And then in check, before items are used as scored items, they should be field tested. And then the data analysis used to determine what items are performing better than others. And lastly, the ACT, data-driven refinement, looking at those stats, determining what items need to be reviewed, and then having subject matter experts use the stats and their own expertise to determine if the item needs reviewing and revising or should it be retired, and having a sound item bank maintenance process so that you can continue to supply the item with the bank with newly written items. So doing things like gap analysis, determining where you need the items to be written, and having different statuses of the items so that you can keep track of where they are in the item development stage. I am a collector of quotes, and I think this quote by Carly Farina, who is the former CEO of Hewlett-Packard, sums up what we've been discussing nicely. Data is only information if it's understood and put into context, and information is only insight if it's utilized to take action. And so that's what we've been talking about. The data you need, how you use that to inform your item writing process, and then how you use that information to inform and provide insightful information to those involved in writing items.